In today's math class, we took a deeper look at trying to find the area of figures and extended it to irregular figures. So the first one we started with was just a review of yesterday's class. We learned that the area formula for a triangle was base times height divided by 2. However, this triangle does not have a classified base or a classified height, so we have to encompass it in a rectangle. So now I have to find the area of the whole rectangle and subtract out 3 triangles to figure out what this middle triangle's value is. So the first one, the rectangle, has a length of 1, 2, 3, 4, 5, 6, 7. So the area of the rectangle is going to be 7 times a height of 1, 2, 3. So the area of the whole rectangle is 21 square units. So now I'm going to use the area formula for a triangle on the remaining triangles. The base of this triangle right here is 1, 2, 3, 4. Its height is 1, 2. So 4 times 2 is 8, divided by 2 is going to give this triangle an area of 4. For this triangle right here, its base is 1, its height is 1, 2, 3, 4, 5, 6, 7 units tall. 1 times 7 is 7, divided by 2 is 3.5. This triangle right here has a base of 1, 2, 3, and a height of 1, 2, 3. And 3 times 3 is 9, divided by 2 is 4.5. So now I've found the area of all of the outside triangles. I'm going to add them together. 3.5, 4.0, and 4.5. When I add them all up, I get 12. Okay? When I subtract the 12 square units from the rectangle's square units of 21, the middle triangle will have an area of 9 square units. So that's what we worked on during class today. So for the EduCanon folks watching this, I am going to give you another triangle, and it's going to ask you to calculate its area just like how I just did, and you will have to write the answer in. I hope you're doing your work on a separate sheet of paper, but please find the area of triangle DEF. Another thing we worked on in class today was the most missed from our EduCanon, which was I believe it was number 5. So let me just check one class's EduCanon questions. Actually, it was question 4. Okay? So here is the question. The students really needed, I haven't taught the trapezoid formula, but a 6th grade standard is to be able to take any closed figure polygon and break it into other shapes to see what its area is. And here I have 3 shapes. I have 2 triangles and a square. So students should be able to do base times height. If this height is 12, this one is 12, divided by 2. 5 times 12 is 60. 60 divided by 2 is 30. 5 times 12 is 60, and 60 divided by 2 is 30. The area of the middle square is calculated by doing 12 times 12, which is 144. And then the students would add the areas of the 3 shapes together. So the sum would be 200. Oh, I have 264, Mrs. Kramer. It's 30 and 30, not 60 and 60. Sorry for that error. So it should be 204. Okay? Then the students and I went on to do lesson 5, which is an amazing lesson. And I just want to give you a brief summary of what we started with. So they gave us a wooded lot in lesson 5, and they gave us some random measurements. Line segment AB is 10, FE is 8, AF was 6, and DE was 7. And then they wanted us to calculate the length of DC and BC. So the students and I looked at this figure, and I really encouraged them to draw a dotted line and to look at this whole thing as a larger rectangle with just a section removed. So to find DC, you really have to know what this piece is and this whole piece here. If this whole piece is 10 and from here to here is 8 from the part of the rectangle above, 8 plus what number is going to give you a total length of 10? And it's going to be 2, because 8 plus 2 gives you 10. So DC's length is 2. And then you had to calculate the length of BC. Well, from here to here would be 6. You really have to figure out what here and here is, and you look over here. From here to here, ED is 7. So this is 7. So 6 plus 7 is 13. So the students, we talked about that, and we looked at some more sections. So they gave us 3 irregular figures, all with the same measurements, and I just walked the students through 3 different ways you could do it. And there's actually a 4th way too. They could cut this into 3 rectangles, okay? Length times width here would be 8. Length here would be 4 as well. 4 times 2 would be 8. This whole side is 9. From here to here is 4. So from here to here has to be 5, since 5 plus 4 is 9. 5 length times width. If I scroll down a little farther, I think that will tell me I have a width of 7. So the area for this section would be 35. And 35 plus 8 would give you a total area for this irregular figure of 51. That's not really the only way you could do it. You could draw 2 lines here. You could do length times width for this rectangle, which would give you an area of 18, which this would also be 2 times 9, which would give you 18. And this is where the students have to do some thinking, and I encourage them to draw imaginary lines wherever they need to make sure that they're getting the right calculations. This whole bottom is 7, so this whole top would have to be 7. 2 plus 2 is 4. So this missing section would have to be 3, which means this would be 3. So I'm going to multiply 3 times, and 4 plus 5 gives you 9. So 3 times 5 would give you 15. And if you add all 3 of these up again, this also has an area of 51. That's not the only way that you can do it. Another way you can do it is draw 1 horizontal line and 1 vertical line. So this would be 2 times 4. This is 4, this would be 4, giving you an area of 8. You could do 2 times 9, which would give you 18 here. Now, you would, if this part was 2, if you take 2 from 7, this line segment would be 5, and this would be 5 as well, since this whole section has to equal a total of 9. So 5 times 5 would be 25. And when you add all 3 of these sides together, you still get an area of 51. Now there's a 4th and a final way to do this. You can find the area of the whole figure, and you can subtract out this section. So if this is 9, 7 times 9, the area of the whole rectangle would give you 63. And the area of this section would be 3 times 4, which would be 12, and I still get an area of 51. So I hope the students see so many opportunities to take irregular figures and break them into whatever they need to calculate the answer. And now I'm just going to show you one last one that I really loved from class today, and it was the area of a trapezoid. And this is different than the one I showed you earlier in the video, because if you drop an imaginary height here of 5, the 2 triangles are not the same on both sides, and you're not sure what the bases are. So it's impossible to cut this into a rectangle and 2 triangles to calculate it. So the students and I in 5th period talked about drawing a diagonal from A to C. You know what? Let me use my shape tool. That's a better diagonal. And now they can calculate the area of just 2 triangles to find the area of this trapezoid. This right here is an acute triangle, and I'm just going to do base times height divided by 2. So 8 times 5 is 40. 40 divided by 2 is 20, so the area of this triangle is 20. The base of this triangle on top is 4. And if I drew an imaginary height here from top all the way to the bottom, this is the tippy top of the shape, it's still 5, okay? So you're going to do 4 times 5, which is 20, and 20 divided by 2 gives you an area of 10. So an area of this trapezoid altogether is 30 square units, okay? And that's a brief summary of the lesson today, and I will be popping a couple of review questions on the end of this video. Have a great day.